A man pulls a sledge of mass 25 kilograms across level ground with a horizontal force of 60 newtons. A constant force of friction of 200 is acting on the sledge. What is the acceleration? Simple question. Let's draw the diagram for it. Here is my sledge, sorry. And the force you're pulling it with is 60 newtons, and it's being held back by a force which is 20 newtons because of friction, right? So what is the effective force towards the right? What is that force? Well, it's the difference of the two forces. So effectively, it's 60 minus 20, which is 40 newtons. That is the net force acting on it, right? Can I find out the acceleration if I know the net force? Yes, I can, which is F net is equal to the mass times the acceleration. Well, this is 40. The mass is 25 kilograms and acceleration is unknown. Taking 25 to the other side, dividing it 40, divide that by 25, you get 1.6 meter per second square. The answer is C. Oh, sorry, it's B. What am I saying? It is not. It is B. A car moves in a circle at a constant speed. What is the direction of the resultant force acting on the car? Well, it's turning in the circle. The speed is constant, so you'd assume there's no force because there's no acceleration. But it keeps turning, so the velocity is changing, right? Because the direction of the car keeps changing. Velocity is not just the speed, but also has direction. So B, it's towards the center that the force is acting because the car keeps turning towards the center of this circle because it keeps moving around in a circle. Two forces of 3 Newton and 4 Newton are acting at right angles to each other. Which diagram shows the resultant force? So it's interesting, and there are multiple ways of doing this. So let's take a look at the first way of solving such a question. Well, one could be a very common sense approach, which is if you have a mass, right, and it has two forces acting on it. So they're at right angles to each other, and one is 3, one is 4. So if this is 3 and this is 4, they're at right angles. So what is the resultant of this force? Now think about it. Let's say person A is pushing this box like that by 4 and by like an effort of 4 newtons, and this is person B is pushing it towards the right with an effort of 3 newtons, right? Which way would this go? Won't it travel this way? So that's the resultant, right? And you can actually calculate the exact resultant if you actually draw a horizontal line, which is 3, let's say, depending on your scale, let's say 3 centimeters long, 3 inches long, whatever. And then you can draw a perpendicular line to it, because this vector is perpendicular, 4 centimeters or inches long, and kind of make a rectangle around it, and poorly drawn, but this vector will be the resultant vector, known as the resultant vector, like R, right? Now here's another way of working on it. One such famous rule is that there is a head to tail rule. You take one vector and then you take the other vector and put it on take the second vector, its tail, put it on the head of the other vector. Do it for all vectors present. We only did it for 2 because we have 2 vectors present. Now, wherever the vector is starting, label that. Wherever the vector is ending, label that. Now join those two together, and that is your resultant vector. Now notice how this vector and this vector are completely identical, right? And there are more ways of doing this. You can make a rhombus out of it, whatever, fancy words. But end of the day, just find an intuitive way of doing it, and you can clearly see that our answer is C over here. Not only that, you can probably know the exact value of this. If you can't measure it, you know, well, it's going to be, this length is 3, this is 4, it's a right angle triangle, so you can figure this length out. We've done it so many times, I think most of you using Pythagoras theorem know that the answer will come out to be 5 newtons. Not that the question asked, but for fun we did it anyway. A force of 1600 newtons accelerates a car of mass 800 kilograms from rest. Excellent. What is the car's acceleration and velocity after 4 seconds? Acceleration is the easy part. We can figure that out by the formula, because we know the force. We have a force and we have the mass, and they're asking for acceleration. What formula to use? FMA. What is that? F equals to ma. The force is 1600, the mass is 800. You can already do it in your head. The answer is 2 meters per second squared. Now that's the force acting on an object. What is the velocity of it after 4 seconds? Right? It's starting from rest. It's experiencing a constant acceleration. So what is the relationship of acceleration and velocity? Well, that's an easy question. Acceleration is the rate of change of velocity, which is the difference of final and initial velocity over time. We know all of these values. Acceleration is 2. Final velocity is something we need, minus u, which is 0 because it's starting from rest at a time of 4 seconds. This will make your velocity come out to be 8 meters per second. Or you could write it like this, it doesn't really matter, meter per second, right? The best answer is D for us. On which car is there a resultant force? A car moving along a straight line, straight horizontal road. So it's moving at a constant speed. So yeah, nothing's happening to it. There is literally zero change of acceleration. If acceleration is 0, force is 0. So A is not our answer. A car moving around a bend at constant speed. Now speed is constant, right? So this part is out, but it's moving around a bend. That means it's turning. This is turning, which means the direction of the car keeps changing, right? Because if the car is moving like that, a few seconds later, if it's here, it'll move like that. So there is a change in direction. You see the direction is now different. So the velocity is a vector quantity, and we understand that velocity is changing. It's changing if the direction is changing. Right? And if the velocity is changing, that means, believe it or not, the car is then accelerating, because acceleration is the rate of change of velocity, right? We did this question earlier about circular motion, or cars in circular motion. We identified the force. That's why the force is in the center. That's where the acceleration is pointing at. So this has a force. All right. Car moving uphill, constant velocity. Well, the velocity is again constant, so there is no acceleration, is 0. And the direction is not changing, so it's still 0. Force again is equal to 0 over here. Car is stationary, big whoop. Nothing is happening over here, it's just stationary. So that's out. Our best answer is B. A parachutist of mass 60 grams falls at a steady speed. Steady speed, right? That's important. It's at steady speed. The gravitational field strength is 10. What is the upward force acting on the parachutist? So it's interesting. Let's introduce our parachutist. He has a weight which is, pulling him down. He is not accelerating, meaning the weight has no effect. Why? Well, the parachute is preventing him from falling fast. He's moving at a constant 10 meters per second. In other words, the acceleration for for my guy is 0. There's no acceleration, meaning whatever this force is, the weight, is being countered by the parachute, right? So there's an upward force by the parachute, Fu, let's go with that, or let's go with like F up, right? That's equal to the weight. Why do I say that? Well, there's no net force acting on this parachutist. Why? There's no acceleration. So what is the net force? Well, F net is the mass times the acceleration. There is no acceleration. So F net is 0, right? And what's causing F net? Well, it's the difference between weight minus the upward force. If this is 0, then weight has to be equal to F up, the upward force. So these are two equal forces. Hence, it's not accelerating, it's just moving down at a steady speed. So these have to be equal. So what's the weight? Well, weight is just mass times g. His weight is, what is it? Mass is, 60 times 10. His weight is 600 newtons, right? And that has to also be this force. The correct answer is D. A force moves a box up a rough slope. The diagram shows 4 other forces acting on it. Which is the force due to friction? So if it's being moved like that, the friction is against the motion, so it's C. The overall stopping distance of a cyclist is made up of 2 parts. The distance the cyclist travels during the reaction time. So he's like, oh, I need to stop, or he's supposed to stop, but he takes some time while he's moving until he hits the brakes. Now he's hitting it and he's slowing down and then he stops here, right? This is the braking distance. This is the reaction distance, or the time he's taking to decide. Not like he's not, consoling the gods or checking his, zodiac. But there is certain delay from a trigger and the response of it by human people, which is known as human error. The distance the cyclist travels after the brake are applied, right? The braking distance is longer when the cyclist is on a wet road. So this is longer if the floor is wet or the road is wet. Why? Well, because if it's wet, the road is slippery, which is another way of saying that the friction on the road is low. As a result, deceleration, I think I really butchered the spelling this time. Deceleration is going to be slower as well. Hence, it takes longer for the vehicle to stop. The figure shows a speed time graph of the car traveling along a horizontal road. Yippee. Explain in terms of the horizontal forces that act on the car why its speed is constant. Why do you think? Well, at 1, look at it. The speed is 30 for all of the 2 seconds the graph is starting. It's 30 for all times. But how do we explain it? Well, the gradient of the graph, or the slope, is 0. It's horizontal, implying there is no change of speed. So let's put that into words. The gradient, or the slope, is 0. Hence, the acceleration is 0, which implies that speed is constant. Acceleration can be 0, that means the velocity is not speeding up, not increasing or decreasing, or speed is not increasing or decreasing. So if speed is not changing, that means speed is constant. Speed is a scalar quantity, or it's actually better. Speed has only direction, only magnitude, whereas velocity has what? Both. Of course, magnitude and direction. The driver presses the accelerator and the speed of the car starts to increase from 25 meter per second. The car accelerates at 1.5 meter per second squared. So the car is accelerating. This is the acceleration, that's A, right? And we know the mass of the body. They're asking, calculate the resultant force acting on the body. Well, what is that? F equals to ma. We know both quantities. The car is 800 and the acceleration is 1.5. That makes the force 1200 newtons. Explain why the forward force acting on the car due to the engine is greater than the value in B1. So the question's essentially asking that this is the car, this is the car, and the resultant, the total forces acting on the car is 1200. How do we know that? Well, we just calculated it because we knew the acceleration. So they're saying that the acceleration by the engine is much larger. Why is that? Well, because the car is experiencing some drag force, some friction, right? So whatever the engine is trying to output, it's gonna get slowly countered by the drag force. Like, not slowly, but some of that force will slowly get eaten away by the drag force. Every cars have it. So the engine's always doing more work, right? And the resultant, the difference of the two is the resultant, which is 1200. And that's the reason. Can we put that into words? Let's try that. The resultant should be capital. The resultant calculated is the force supplied by the engine minus the friction. Or in other words, you can say the force by the engine, let's call it force of engine is exactly 1200 newtons higher than the resultant that you just calculated. This is easy. Determine the speed of the car 4 seconds after it started. The acceleration is 1.5. The velocity is something you want to find out. And what's interesting is the initial velocity is not 0. It was already at 25 meter per second. Right? This car over here was already moving at 25 meter per second, then accelerated by this amount, meter per second squared, for 4 seconds. So how do we do this? Well, same equation, but don't forget to add the initial velocity over there. What is it? Well, it is A equals to V minus U over T. A is 1.5, V is V, U is 25. Divide that by the time it took. All right, 1.5 times 4 is 6. So V minus 25 is 6. V equals to 25 plus 6, which is 31 meter per second. Now, this is the velocity. It makes sense because it accelerated for 4 seconds and it was at 25, right? So now the velocity is more than 25. That should make sense. That should make logical sense. Like, if you got an answer like that, that's like 7. But like, if it's accelerating, why is it lower now? So those are questions you should be asking. But I hope this made sense. Let's move on. Figure shows a man pushing a heavy box with the force P. A friction of the force acts in the opposite direction. So that's F, and he's pushing it. P for push, F for friction, I guess. State what is meant by balanced forces. That all individual forces add up to 0, or the net or the resultant force or the net force is 0. The frictional force in the figure does not produce any heating effect. So as soon as he pushes it, the friction is stopping it from moving, right? The box is stationary. The box needs to move for the heat to take place, right? If you're trying to push something and it's not moving, it's not gonna, generate heat. So it has to rub or grind or whatever against another surface. So the box has to, let's go with a little technical answer, even though we can say move. We can say the box needs to be in motion because it needs to rub against it. Apart from being stationary, describe one other possible state of the motion of the box when the forces are balanced. So forces are balanced, but what could be another motion? It's stationary. Well, forces are balanced. Essentially, that's another way of saying that the net force is 0, right? F net is 0 and acceleration is 0. So if this is stationary, it won't move. But if it's already moving, it won't speed up or slow down. So it'll move at constant speed. Motion with constant speed. All right. So when P is 100 newtons and F is 85 newtons, the box accelerates. The mass of the box is 25 kilograms. So, well, what is the resultant force? The F net is the difference of these two forces, which is the push force minus, because the frictional force is countering it, right? So that's 100 minus 85, which comes out to be 15 newtons, right? And the acceleration can be known to us by rearranging F equals to ma, which is going to be F over m. I can just put it directly, but here's a slightly different way of doing it. 15 over 25. This is 3 over 5. Put that in a calculator. You will get 0.6 meter per second square.